Alright, so we're going to start 1.2 points, lines, and planes. Just, remember, make sure you guys are watching these videos. If you're watching this, you're doing that, but remember you can pause them, go back, write definitions down, and use these things on the tests and quizzes for the most part. Um, that being said, we're going to start off today with a lot of vocabulary. A lot of it you've heard before, but in geometry, we um, a big element of it is being systematic and the way we go about things. So we're going to start with very basic things, and we're actually going to start before we even get to our definitions. We're going to talk about undefined terms. You know, from English class, if you're going to give a definition of something, you can't use that word in the definition. Same kind of thing happens in geometry. So when we start to try to talk about a point is actually one of these undefined terms because basically point is just a concept. You can't really define it with other known words. You just have to um, talk about it and agree what a point is. And what we say a point is it has no dimension. Okay, it has no dimension. It's often it's in a picture. It's a picture of a point, and we can label it. We use a capital letter and just one letter. Okay, that's the point A. So one capital letter is how we name it. Name one capital letter. Let me try to switch. That's the picture. Okay, a line that extends in one dimension. So a line extends in one dimension. Um, it's drawn straight. So in math, lines are always straight. If you start talking about things that are curved, like this is not a line. That's what we'd call a parabola. A line has to be straight. Okay? And what we're going to do is there's two ways to name it. Okay? I'll put 2 points on that line, and I can name this line. So we name it by saying it is line AB with a line with arrows over the top. Now, there's a second way we can name it. Maybe pick a different color. So I'm going to come back here. Name with 2 points. Two points with a line on top. Now the second way you can name it is sometimes they have a lowercase letter, and it's often kind of a cursive letter. You can use just one lowercase letter, and you can so if you have a lot of different lines crossing, they oftentimes will try to just use one letter to talk about that line to make it a little bit simpler. The next thing, a plane extends in 2 dimensions. Okay, it extends in 2 dimensions, and if you're going to draw a plane, oftentimes you draw a rectangle. Okay, now it actually would keep on going in these directions. So I think of like a plane as a sheet of paper. Sheet of paper or a wall. Okay, it's flat. It has no dimension in that flat side, and it extends on in those directions. It just keeps on going. So the ways you can name a plane, oops, we can name a plane by saying this is plane, and then you'd have like a capital letter here, plane M, or using points on the plane. Say we have point A, B, and C. I know that's really small, but you could also just name it plane A, B, C. Okay, 3 points will define a plane. We'll talk about that later on, but it's important to know. And we still have some more vocabulary words. Okay, these things aren't going to go away after today. You need to know what collinear means and coplanar. Collinear is points that are on the same line. Okay, coplanar points. Okay, collinear, linear, think line. Coplanar, co is kind of with, so it's with the same plane. So points with the same plane. It's an S, points on the same plane. Alright, now a line. So we can have a line. We basically talked about it up before, but we talked about the name up there already. I guess that's what I was going to do here. So let's forget that. Let's move on to line segment. That's the more. So we've already talked about a line. Now a line segment consists of the endpoints A and B here. So it's only part of a line. Part of a line. Okay, it stops at A and B. A and B are the endpoints. Endpoints are where it stops. Just kind of like what you would think it would mean, right? Okay, so endpoints on a line is where it stops. A ray has one endpoint, a part of a line. So here it had 2 endpoints. A ray will only have 1 endpoint. Alright, so you imagine, you want to think of a ray, where you often hear of a ray. You know what I'm drawing here? Right? Seen this thing before? Terrible drawing, but I'm a math teacher, right? Remember that? These are all rays coming out of the sun, right? Sun rays. That's a ray. It has an end point, or basically, in this case, an initial point. It's where it starts, and then it goes on out, okay? So end point with the ray, actually, they call them initial points, where they start. Now we need to talk about how we name a ray. Okay, so like up here, if I wanted to name this line segment, I could name it line segment AB with a line over the top. Notice there's no arrows. It's just a segment. It does not keep going. And that would be the same thing as line segment BA with no arrows. Now with array, I'm going to need some points here. So I'm going to keep using A's and B's. So array AB starts at A and goes through point B. Now, how do I tell the difference between a line segment, a line, and array? Remember, the line had 2 arrows, line segment has no arrows. Here we're going to have 1 arrow. Okay, that's my array AB. Now, this does not work. Okay, and what we do is it starts, the initial point is where it starts, and when we list array, because it matters where we start the array, if we start at A or B, the first letter is the initial point. When we name it. So this one did not work. This one works because array BA would actually be like an array that would start at B and go through A this way. Sorry. Let me try to do a different color. That would be array BA, starting at B, going through A. It's going the opposite direction. Which brings up opposite arrays. It's going to be an array that goes in the opposite direction. And oftentimes they'll have the same initial point. It's kind of unclear if it try to make it have the same initial point, but just going opposite direction. Intersect means they intersect. They have more than one point in common. Or more than, well, I shouldn't say that. One or more than one point in common. Okay, and that one, it's kind of common sense, I hope, but these lines intersect, they have one point in common. You could also have like a plane. Remember, we draw a plane with a rectangle, intersecting a line. And then where it goes through the plane, I use a dotted line. Here, this line intersected the plane in one spot. And I could also draw a line in the plane that intersects in more than one spot. Alright, so we got some examples. We already got to start moving here. Try to get you to your the rest of your night here. Name 4 points that are coplanar. Coplanar means all on the same plane. So I look at this and I say, these 4 points are all on this rectangle. Okay, I could put a sheet of paper right on that rectangle, and those 4 points would be all on there. We can say points L, M, N, and O. Those points are all coplanar. I lost my point M there. Alright, next one. Name 4 points that are not coplanar. I need a point. So I could have 3 coplanar points and then a 4th one that's not, and those 4 points would not be on the same plane. So as long as one point is not on the plane with the other ones, they're not coplanar. So I look at this, I'm going to pick 3 points. I could pick any 3 of these, except for I wouldn't want to pick a set of collinear points. Because if you think about it, if these points are all on a line, I could kind of draw a rectangle off the page and have it hit that point P. Imagine a sheet of paper coming off the in 3 dimensions coming off, following this line up to point P. So I would not want to pick those 4 points. That would actually be another set of points. So it only says name 4 points, so that's an answer. But I could also have picked P, L, N, and O. Those 4 points are also coplanar. So I want to pick something else. So let me get rid of that plane. I want to make sure that I pick 3 points that aren't collinear. So I'm going to pick these 3, 1, 2, 3, and then a 4th point that's off that plane. So these 3 points are on one plane, the 4th point that's not. So I'm going to say N, O, M, and P. These 4 points are not on the plane. Okay, I don't need 4 groups. This is a point right here, right? Point N. And then name 3 points that are collinear. That one's collinear. Remember, linear means line. 3 points that are on a line. My only option here is L, N, and O. So here, we're going to practice drawing. Drawing is very key for word problems. So we're going to practice draw 3 collinear points, A, B, and C. So those points need to be in a line. And then they say, and a point B, which is off the line, which is not collinear with A, B, and C. So let's call this B over here. I want to draw line AB. Now if I draw line AB and C is collinear with line AB, I know that line's just going to go all the way through C. So I'll extend it out. And then they want me to draw ray. Notice this is ray. This is a line. Right? Maybe I'll over-explain this, but it's important. Notice the notation. That's a line. That's a ray. Now, notice there is more than 3 points on this line. How many points do we need to label the line? Just 2. 1, 2. Because I knew that third one would hit anyways. I just need 2 points when I'm labeling a line. And ray BD. Now, does that go this way, starting at D and going this way, or B and going towards D? B is my initial point. It started there, goes through. And that's the picture they wanted us to draw. Name 2 pairs of opposite rays. I'm just going to pick a point, G. If that's my initial point, I could have a ray that goes this way, ray GH. And now what if I wanted a ray that started at G and went this way, right? So I could have a ray G now goes through F, so I could either call it GF or GE, but G had to go first. Okay, these would be opposite rays. Even though this arrow and this arrow are going in the same direction, they're opposite rays because I look, okay, I'm starting at G, I'm going towards F. Starting here, going this way. Okay, that's ray GF. Sketch the figure described, a line and a plane that do not intersect. One way to draw planes in 3 dimensions, if you know you need to do 3 dimensions, and you want multiple planes, I like to draw a box. Okay, so now I can draw, here's my plane. I can kind of shade it in, here's a plane, and then I can have this line back here that does not intersect this plane. See how it's back behind the plane? The next one, 2 planes that do not intersect and a line that intersects both of them. I can do the same concept, draw 2 planes here and draw a line through them. I'm actually just going to pick 2 rectangular shapes. Now, these rectangles kind of look like parallelograms because they're in space. But I'm going to draw my line. It's going to intersect here. Dot, dot, dot. It's going through it. And it's solid once I can see it again. Dot, dot, dot. I can't see it until it's through. That's my drawing of a line intersecting two planes. These planes don't intersect each other. They are supposed to be parallel. There's the homework assignment that we'll be working on tomorrow in class. Have a good night.